everyone. So we will tackle on the introduction to integration in basic calculus, grade 11, the antiderivative of polynomial, rational, radical, and exponential functions. So these are our topics covered from this presentation. Okay, we have here the concept for getting the antiderivative of the function. We have here integral of f of x dx is equal to x raised to the power of n plus 1 over n plus 1 plus c. Wherein, as we can see in the exponent part, n plus 1 can also be observed in the denominator part. So it means that whatever the quantity in the exponent will be the same quantity in the denominator. So plus c, c is referring to any constant because since antiderivative is the process of wherein it will be considered as the reverse of getting the derivative of the function. So if you could still remember, when you get the derivative of the constant, the answer is 0. But for integration, we are trying to identify the constant term that has been removed as we get the derivative of the function. So ibalik na to, where n is not equal to -1. Next, the following are the terminologies and notations for anti-differentiation. So first, we have anti-differentiation is the process of finding the anti-derivative. The symbol, that one, also called the integral sign, denotes the operation of anti-differentiation. Third, the function f is called the integrand. After the symbol, that function or the quantity is called integrand. Fourth, if we have here this capital letter F is an antiderivative of f, we write down integral of f of x dx is equal to f of x plus c. Next, the symbol, that one, and d of x go hand in hand, and dx help us identify the variable of integration. The expression f of x plus c is called the general antiderivative of f. Meanwhile, each antiderivative of f is called a particular antiderivative of. Okay, so we have here the following illustrative example. Find the antiderivatives of the following functions. 1. Integral of 2x plus 1 dx. This one is a linear function. Second, number 2, integral of 2 over x plus 1 dx. This one is referring to the rational function. Third, integral of x times square root of x minus 1 dx is referring to radical function. The fourth one, integral of 2 raised to the power of 2x dx is referring to the exponential function. So let's integral of the quantity 2x plus 1 dx. So we have here integral equivalent to, as we get the antiderivative of integral of 2x plus 1, we have to use distributive property wherein the symbol integral can be distributed to each term of the given function. Next, we can actually now factor out the constant of these terms. The first one is we have 2. Okay, so we have 2 times integral of x dx plus the second term we have 1 integral of dx. Next to that, we can now make use of the fundamental concept of the anti-differentiation wherein we will add 1 to the exponent and the quantity from the exponent will be observed also in or found also in the denominator part, plus x plus c. Next to that, simplifying, we get 2x squared over 2 plus x plus c. Then by simplifying, we get x squared plus x plus c as our final answer. Now let us proceed in number 2. Here we have here integral of 2 over x plus 1 dx. At this time, we are going to let u be equal to x plus 1 because since this one is a rational function, so at this time, we are going to determine which will be our u or our value of u at this time. So we have here u is equivalent to x plus 1. Then as we get the derivative of this u, we have du, then is equivalent to dx because the derivative of u is 1. Then we write down du, so we have du. For the derivative of x plus 1, the derivative of 1 is 0. Then for x is 1, so we write down dx. So that's why we write down du is equal to dx. Using the general rule, we have integral of 1 over u du is actually equivalent to ln of u plus c. So that is how we are going to process or to get the antiderivative of a rational function. Next, so from that, we can actually factor out the constant. We have 2 times integral of 1 over u du from the given. No? Instead of writing x plus 1, since we let x plus 1 be equal to u, so that's why we have here 1 over u. Wherein the constant, which is 2, has been factored out. Next, that is actually equivalent to, from that, we are now using the general rule. So we have here 2 times ln of u plus c. Then we know that our value u is x plus 1, so we can have our final answer now as equivalent to 2 ln of x plus 1 plus c. Number 3, integral of x times square root of x minus 1 dx. So this time, we will have to decide among x and x minus 1 as our value of u. So as we observe that we can have our x minus 1 as our value of u. So we let u be equal to x minus 1, and the derivative of u is du. The derivative of x minus 1 is 1 or dx. Then from that one, u plus x minus 1 is 1. We can also identify the value of x, which is equivalent to, if we transpose this negative 1 to the other side, so we have x is equal to u plus 1. Then we have here, instead of writing x in this part, integral of x times square root of x minus 1 dx, we now have the value of x, which is u plus 1. So we write down u plus 1 times the quantity of u to the power of 1 half. Because x minus 1 is our u, okay? Where did we get 1 half? Remember the square root or the radical symbol, the square root is 1 half, no? 1 half yung equivalent. So we use rational exponent. So we have u to the power of 1 half du. Next to that, we will have to use multiplication using distributive property. So we have u to the power of 1 half times u. We get now u to the power of 3 over 2, because as we are going to multiply the quantities that have the same base, we will have to add their exponent. So we know that in the first one, in here, we have u, and u times 1 half. In the first one, we have to the power of 1, and the second is 1 half. So 1 plus 1 half becomes 3 over 2. Plus 1 times u to the power 1 half is equivalent to u to the power 1 half du. Now we can now use we can now get the antiderivative, because we already have to use, or we're already using distributive property. So pwede na natin magamit. So we have here, when we add 1 to the exponent, we have 3 over 2 plus 1 become 5 over 2. So we have here the exponent as 5 over 2 can also be seen or observed in or found in the denominator part. So that's why we have 5 over 2 as the denominator. Plus, we have from u to the power 1 half, we added 1. So 1 half plus 1 is equivalent to 3 over 2. So the same quantity also can be observed or found in the denominator part, which is 3 over 2 plus c. Then, getting the reciprocal of 5 over 2 and 3 over 2, we now have 2 over 5 u to the power of 5 over 2 plus 2/3. That is actually the inverse of 3 over 2. We have 2/3 or reciprocal. So we have 2/3 u to the power of 3 over 2 plus c. Next, because we have here the value of u, which is x minus 1, so we can have our final answer as 2 over 5 times the value of u, which is x minus 1. So we have x minus 1 raised to the power of 5 over 2 plus, we have here u to the power of 3 over 2. So we have x minus 1 to the power of 3 over 2 plus c as our final answer. The fourth one, okay, solution for number 4, integral of 2 raised to the power of 2x dx. So at this time, we are going to use the general rule that is referring to the exponential function. But first, let us have to let or identify our value of u. So we let u be equal to 2x from the exponent. Then as we get the derivative of u, we write down du. Then the derivative of 2x, we have 2 dx. Next to that, okay, so we can now have or use the given quantities to solve for number 4. So instead of writing 2 to the power of 2x, we write down integral of 2 to the power of u, but we know that u is corresponds to x. So du times 1 half, because as we get the value of dx, that is 1 half du. So that's why du over 2. Next to that, 1 half integral of 2 u, because we factored out 1 half, so we have 1 half integral of 2 to the power of u du. Next to that, using the general rule, integral of a to the power of u du is equivalent to a to the power of u over ln of a plus c. Next to that is equivalent to 1 half times u to the power of 2 over ln of 2 plus c, because as we can see in the first concept in here, 1 half is being factored out, so we have 1 half times 2 to the power of u ln of 2 plus c. Finally, we have here 2 to the power of 2x over 2 ln of 2 plus c. So I hope that those concept or topics that have been discussed in this presentation will help you particularly in answering your activity in basic calculus.